Hello, everyone. Welcome, and if you want to take a seat, if you're not sitting down yet, hopefully the remote attendees can hear me. So my name's Andy, and welcome to the second round of the rebooted Melbourne NLP Meetup. After its previous long hiatus, we're back here now at Seek, our very generous hosts, and thank you so much to Seek for organising this, for sponsoring this, hosting, doing all the amazing catering work. Also, quick thank you to ALTA, the Australasian Language Technology Association, who is the ongoing Meetup sponsor, and also CultureAmp, GoOne, and Melbourne Data Analytics Platform, who are the employees of the sort of core organising team. So we're trying to run these meetups once every couple of months. If we have either volunteers for presenting or sponsoring, especially if you're an employer or can twist your employer's arm into doing it, that would be great. And so reach out to us in person or via the meetup page, via LinkedIn, any way you'd like to find us. And so we're looking for sponsors for venues for food over the next next few meetups coming up. And that is all you need to hear from me. I'm going to hand over to our very gracious host, Aditya, who's going to take you through the rest of the amazing proceedings.
Thanks, Andy, and welcome. My name is Aditya Joshi. I am a data scientist here at Seek. Before we begin, we respectfully acknowledge the traditional owners of this land, the Wurundjeri Woiwurrung people of the Kulin Nation, and their continuing custodianship of the land, waterways, and community on which we all rely. I would like to pay my respects to their elders past, present, and future, to them, to their rich cultures, and extend this respect to all Aboriginal and Torres Strait Islander peoples present here. So welcome here in this beautiful Seek office. We are excited to present global scale NLP at Seek. Ambiguity and ambiguity resolution, as you know, are at the heart of NLP. All of us have heard of the classic example, I saw a boy with a telescope, where the ambiguity is you don't know if the boy was holding a telescope or if you saw them using the telescope as an instrument. I would like to start this by telling you an ambiguity story related to my experience at Seek. When I got a job offer at Seek, I told my friend, hey, you know what? I got a job from Seek. The ambiguity there, which my friend did not understand, was, do you mean you got a job offer from Seek, the company? Or did you get a job offer using the Seek app? That's really how good the app is. And with that, let's kick things off. We would like to start off with an introduction to Seek AIPS, who is an organizer of today's event. And to do that, I would like to invite our Director of Machine Learning, Eugene. So let's put our hands together for Eugene, who will introduce us to AIPS.
Thank you, Adi. Hello, my name is Eugene Svistanov. I am a Director of Machine Learning here at Seek. And I will not take too much time with a long introduction because I think Seek as a company probably doesn't need a great introduction. But just to put it in the context, we'll be talking a lot about NLP and language and other interesting challenges we're facing. And that probably puts it in the context, why exactly we're doing that and what drives us to do it. As many of you know, Seek is a leading marketplace for employment in Australia and New Zealand. And probably some of you also know that we're leading employment marketplace, not just in Australia and New Zealand, but across Southeast Asia, Pacific, and Latin America. That brings interesting challenge for us, how to solve the problem we want to solve, how to bring the best possible opportunity to the candidate who is looking for it, how to find the best possible candidate for the vacancy the hirer is trying to fill in all these markets using just one platform, using just similar approach that we could use in Australia, in Indonesia, in Philippines, and other places we're operating in. And we approaching it, trying to solve this problem at scale in our team. So we are AI platform services team who looks after machine learning, data science, NLP, and ontology science to address this challenge. We're a cross-functional team of data scientists, engineers, product managers, ontologists, and analysts who are looking into this problem from various angles, and we're trying to address it in several domains. We're trying to define what is important for our end users, what is important for our candidates and advertisers and hirers. It is important for them to discover each other, and hence we have a job discovery or career discovery domain that tries to address these challenges in search environment, in recommendations environment, in related search and other search related scenarios. We have issues of candidate quality. Is it the best candidate? Who is the best candidate? How we define what makes candidate the best candidate for the role? How objectively we can reason about it. We have, for that reason, a candidate quality domain that looks into all these challenges. And last but not least, we have pricing and performance focus, where we need to understand what is the fair value in our marketplace. Are we delivering on our promises to advertisers and hirers? Can we do better with redistributing candidate attention between high-performing ads and low-performing ads? To support all of that, we have our marketplace knowledge team that tries to identify entities and concepts that are important for us to operate in this marketplace, and helps us to make sense out of this unstructured data, out of all employment-related documents we have. And that creates a foundation other teams can build their services upon. So it's just very brief introduction to what AI platform services is at Seek, and I think we will hear tonight from our team members in great details how they face all these challenges and how they solve those interesting problems. I don't want to take any more time, and I think I'll invite the first presenter.
And so let's get started with our first speaker, who, like the name of our event suggests, it is Global Scale NLP. So our first speaker is joining us all the way from New Zealand. So please put your hands together for Case. Case, if you can hear us, can you please start sharing your screen?
Awesome. Okay. Yeah, so I noticed there's a lot of content, so I'll try to go really fast. What I wanted to do today is not so much hardcore research, but show you something practical, which I think, be quite interesting for most of you, and maybe useful even. And so I called it Going Multi-Lang, and it's about machine translation. So we since we have lots of markets with different languages, we need to have a way to make our models understand multiple languages as well. And there's various ways to do that. And the most straightforward one is actually just use plain old machine translation. I did that using a Spark cluster, and I'm just going to show you how does that work. So I'm Case. I work at the candidate quality team. One of the things I look after is Deep Match, which is the model behind Top Applicant Badge, which is the little badge thing that you may or may not have seen if you're a user of Seek. That sometimes shows up if you look at a job and says, "Oh, you might be a good candidate for this." And yeah, this thing needs to go multi-market, multi-language as well. And so one of the ways we may be able to do it is by using machine translation. Yeah, a little bit more details about my team, candidate quality. So in the middle, you see CQ score. This is basically the core model that we use to do to measure the fit between a candidate and a job. Top applicant badge you see at the top is one thing that builds on that. there's some other derivatives of this model as well, but there's also a couple of other things we look after. One is CV parsing, which, as the name suggests, is just reading in PDFs or images or Word documents of CVs and turning them into some sort of structured text format. There's role requirements, which is basically us suggesting to the hirer certain screening questions. For example, like, do you have Australian citizenship or PR? And then there's like basically named entity recognition of the important bits of information in jobs and CVs. And we don't only detect them, we also normalize them. So we basically, things like must have driver's license or whatever will get normalized to a standard term for a particular type of driver's license. Yeah, so what I said, there's a couple of ways that you can do it. Make a model multi-language. And I listed them out here. The main one, I guess, is just train your model from scratch on multiple languages. And this is great if you have infinite data and you have infinite compute. And we not quite there yet. So it's certainly an option, but even, if you can manage to train your big giant transformer from scratch, it's not an easy process. It takes a couple of days on many machines. You want to make a small change, you want to add a new language, you want to compare some hyperparameter versions, it quickly explodes. And so if you can, it's usually better to avoid it and use an off-the-shelf model. Then there's models called language agnostic sentence embeddings. So both Google and Facebook, I think Google released LabC in 2020, and Facebook released a model called Laser in 2019. I'll talk a little bit more about those in detail later, but they have this concept that you feed it a sentence and out comes a vector. And it doesn't really matter what language the sentence is in. So that's a nice option. And then option 3, to me, it's very obvious, is actually machine translation. Yeah, so training from scratch, I already kind of pointed it out. It's nice if you can do it, but it's generally not very practical. And yeah, we actually using the Amazon data centers, and they don't have the latest and greatest GPUs. They have them in the US, but not in Australia, and we can't just move all of our data all over the world. So it's not the most practical solution for us. Language agnostic sentence embeddings are very interesting. It's very nice, and the big advantage of these things is that once you have the model trained on your vectors, you can basically run it on any language that these models support. LabC has 107, Laser has over 200, I think. So it's nice, but there's some disadvantages to this as well. So one disadvantage is they're general purpose sentence embeddings. So they're trained on the internet, and yeah, we have a very specific kind of language, right? We have job ads which are very specific. They have very specific phrases and terminologies, and CVs is same story. So we actually have fine-tuned embeddings. We have text embeddings that we use for our models, but yeah, they're fine-tuned on our specific domain-specific data. They can't handle long sequences is another problem. This is a recurring problem with anything related to transformers. Most transformer models only go up to 512 tokens, and after that, it's just bad luck. So yeah, you have to do something about it. You can chop up your document or something, but it's not so easy. And then the other problem with these things is, yeah, if you fine tune them, so transformers you can fine tune on your own task, but if you fine tune one of these language agnostic models, the input language may diverge. So say you have a vector for the English language, I like cheese, and I have this vector also represents the French language, j'aime le fromage, and then I'll go fine tune, and these two might diverge, and they may no longer be the same vector again. So this is another problem you have with these vectors. Machine translation, yeah, it kind of feels like cheating. I personally, actually, if you think about it, it's not. It's almost the same as having agnostic fixed size vector embeddings. But they're not fixed size vectors, they're language agnostic sequence representations. And so, and that's really just a fancy word for a single language. Once you have those, you can just train on your one language, and it has it means you can keep using your carefully fine-tuned embeddings. It means you can keep using your models specific to large documents. So we use like a Big Bird derivative model, which uses sparse attention, so you can read bigger documents in one go. And also, it's just quite advantageous to have a translation in the first place. So not everybody speaks Thai, not everybody speaks Chinese, but most people in our organization speak English. So it's nice to have like a representation that everyone can understand. Yeah, so I settled on Marion MT, which is a whole series of language models available on Hugging Face. I think they originally came out of Microsoft, but you can correct me if I'm wrong. And then somebody from University of Helsinki ported them to Hugging Face and put them on Hugging Face Hub. And they're pretty good. They're not too big. They're all under 300 megabytes. And there's quite a lot of language pairs available. The problem with, one thing about these models is they only come in pairs. So you have a source language and a target language for the model. So you need to pick the correct model, which means you need to do language detection first. And so for that, I use fast text, which is a library that many people probably know out of Facebook, famous for the word embeddings, but it also has like text classification functionality, and it has a pre-trained language classification model as well. So yeah, fast text works on lines, not it complains if there's new lines in your inputs. So what we ended up doing is just splitting the documents on lines, and then fast text will return an array of probabilities and an array of languages for every line. Then we take the weighted average of those, so that you get weighted by line length. So if there's large portions of the document that have high confidence for a specific language, they will get a high contribution to the score, and short fragments that have a low probability, they will have a small contribution to the score. And then you end up with kind of like a weighted average for the whole document, something that you see at the bottom in the screenshot, and it works pretty well. This is an actual example. It's kind of interesting here to see. I think FastTech was very confident about the languages, and you see the numbers actually represent the length of the spans rather than the confidence levels. Because the longest one is French, the middle one is German, and the smallest one is English. Yeah, and then if you run this thing on basically all of our data in Hong Kong and Thailand, which is the two countries I picked for the pilot, we come up with this. So it turns out most of the job ads and most of the CVs are actually considered to be English. And when I say considered to be English, means more than 80% English. And there's only a small section that has 20% non-English or more. And well, you see here it says more than 20% Chinese in Hong Kong and more than 20% Thai. There are some documents, so job ads or CVs that have other languages than the second language, but it's actually very small. It's only a handful. So I left them out of these pie charts. But still, it's a significant piece of the pie. So we need to address that. Yeah, and so that's where the translation functions come in. So what I ended up doing is build a bunch of user-defined functions in Spark. I'll get back on that a little bit later as well. And I kind of packaged them away in a Databricks notebook, and I kind of created this factory function that just loads, in this case, Helsinki NLP Opus MT ENES, and it registers it under the name English to Spanish. And this, to me, still feels a little bit like magic. You can just use it in your SQL queries, and I love it. I think SQL is great. It's like over 50 years old or whatever, but the idea that you just can write Python functions and register them and run them in your own queries, I think is awesome, and it works like a charm. And the nice thing about Spark is that it does all the scaling for you. So if you want to do this on one document or 10 documents, fine. If you want to do it on 10 million, no problem. Spark will just spin up more clusters and run more of them in parallel. Yeah, here's some details about so going tiny bit more detail about the Spark UDF. So there's two types. There's the Spark standard UDF and there's the Pandas UDF. And the difference is that the normal UDF just runs the function on one input, so like basically one cell. Whereas the Pandas UDF, they take batches of Pandas series. And the good thing about that is that it gives you some time to set up your model, which is an expensive operation normally. You need to load several hundreds of megabytes into memory or into the GPU. But once that's done, you can start iterating over these batches of Pandas series, and you can run the inference on those. Once you're done, I found it's actually normally a good idea to actually delete the model and do a bit of garbage collection. Otherwise, sometimes you run into out of memory issues. And it's the same story. You register it and you just happily run it in your SQL. Speed. Turns out the way I set it up, it's about 1.6 seconds per document. This is on a G4 on Amazon, which is has a GPU, not a great GPU. There's definitely room for improvement there. Like, for example, I'm doing one document at a time, just doing the line splitting for that document, then doing the tokenization for them, and then do the inference, then putting it all back together. This can all be, optimized, but still, I think it's pretty good, and it's good enough. So, if I spin up like 40 instances, I get pretty good performance. Here's some examples. So this is Thai. I think if you look at I don't speak Thai or read it, but the translation looks pretty English to me, and I think it's pretty good quality. Here's some Chinese. Looks slightly less good, but I've been told that the Chinese actually is not that great either. So, in that respect, they probably did a pretty good job. Yeah, and then some gotchas and tips. One is, okay, you have to split up your documents in a smart way. And that is a little bit of an open question to me, like what is the best way to go about? I ended up actually using Markdown. So our job ads are in HTML. I just use this library called Markdownify to convert them to Markdown and then split the Markdown on lines. It works really well. Use Spark iterator of series to iterator of series UDF. So there's a whole bunch of Spark UDFs. This is the one you want to use. Because it allows you to set up the model, then loop over these big batches. Don't forget null is another important one. The SQL has no values and you have to deal with them. Use a GPU if you use the Hugging Face models, big transformer models, they all run faster on a GPU. And then, the last one, I haven't actually completely measured it, but you do have to be a little bit smart about query planning. So you see here, for example, select distinct English to Thai document. Yeah, what does the query planner does not know that English to Thai is always going to give the same result out of the same input. So it will probably first run English to Thai on all of the documents and then pick the distinct ones. So sometimes you have to help the query planner along a little bit as well. Room for improvement. So this is the kind of stuff I ran into. I thought, oh, would be nice if this was there, but I don't think it exists yet. So these might be interesting ideas if you are looking for open source project to contribute to.
Sorry, Case, it might be useful to wrap up in a minute. I'm sorry to interrupt.
Yeah. So better language span detection, which I think would be a really cool project to do on a bird model or some sort of big transformer model, which you could train with synthetic data. Better multi-language sentence splitting would be cool. There's good sentence splitting which is slow, and there's fast sentence splitting which is not good. So that's an interesting project you could work on. And then a better way of splitting large documents that's still a little bit of an open question as well. And and the other thing is this whole thing, it works on other stuff as well, right? It doesn't have to be on machine translation. And to me, this has been the theme recently. It's like once you have a Spark cluster, everything starts looking like SQL. And that's it. That was me. So I don't know if we have time for questions.
Thank you, Case. So that was Case from the Candidate Quality Squad. Sorry, Case, we do not have enough time for questions. Okay. But for those of you who are interested, we have a few other members from Candidate Quality Squad here. We are going to take a break, so please feel free to ask them a few questions. Let's move on to our next speaker. So the next speaker is from another squad. So like Eugene told us, AIPS has several squads. So the second squad who will be talking about their NLP work is Marketplace Knowledge. And we have Sylvia joining us from Sydney. So over to you, Sylvia.
Thank you. So hello, everyone. I'm Sylvia. I'm a senior data scientist in the Marketplace Knowledge Squad. And today I'm going to talk about domain adaptation using fine-tuned multilingual models. So our purpose at Marketplace Knowledge is to transform the SIG data into rich, meaningful, and connected assets to enable personalization, transparent matching, and trusted insights. And our main focus areas are to provide structured data assets and services to other teams in SIG, exactly as Eugene already mentioned, to provide enrichment services through entity normalization, classification, and suggestions. And we also do a lot of work on graphs and graph services by using various ML algorithms. SIG has a lot of data coming from 50 million candidates and 300,000 hirers. And a big part of this data is expressed in human language that is very varied. Because there are many ways for expressing the same thing, we have challenges in understanding and creating meaningful structured data. In order to address this problem, we apply various processes on our textual data, and one of them is the job title normalization. In order to give you a feeling of what the job title normalization is and the problems that we face, I present 3 job titles that refer to the same role, which is the membership sales manager, but each title is different of the others. So through job title normalization, we want to recognize that entity that refers to the role advertised in the input text without removing any important content. And we want to link it to a standardized representation that we will call normalization. Here we have other examples of SIG job titles and their normalization. The first example contains not only information about the role advertised, but other additional information like the salary or the schedule. The second example has more than one normalization. It refers to a stainless steel metal finisher and the laborer. It is also important to fetch the important information at different level of granularity depending on what our partners need. And the last example is a clean, nice text that contains only information about the role advertised, which is metal polisher. Being able to normalize SIG job titles helps creating better recommendation to both seekers and both job seekers and hirers. It will make also easy for candidates to search for jobs, and it also enables more accurate aggregations and corresponding market insights. There are various ways to approach normalization problem, and here we are going to discuss what we consider the 2 most popular ways. The first approach is the lexical approach that is a keyword-based. This approach works at the keyword level, so it doesn't understand the meaning of the input text and which part of the text is important for the job title normalization. Here are a few examples of erroneous normalizations. From assistant to CEO, a lexical approach may normalize to chief executive officer. That is a very different role in terms of the skill necessary to do the role. From campaign management trainee, a lexical normalize to campaign manager. And in the last example, we can see that we have first the information about the role advertised, followed by the company name. However, the lexical approach cannot detect this information. Therefore, it may provide as possible normalization commercial accountant that is very different of the intention of the hirer. The second approach is based on neural networks and sentence embeddings. This approach understands the contextual meaning and encodes the text semantics. As we can see in the first example, this approach is able to understand that the ad is about assistant to CEO and not for a CEO. And in the last example, this model provides financial accountant as the correct normalization because it is able to understand that the last part refers to something or else than the name of the role. The way how embeddings approaches work is that the noisy input text is passed through an embedding model that maps each input into a vectorial space. And here's a few representations of few input text. So for, the first example is the previously seen long title about metal polisher. And we expect this to be mapped to a vector representing the metal polisher concept. The second input is metal finisher, and we expect to be mapped to the metal finisher concept. While the second input is assistant to CEO, that even if it uses an abbreviation, we expect to be automatically mapped to executive assistant to the chief executive officer vector. The vectorial space represents the domain knowledge, and we expect concepts that are semantically similar to be close in the space, while concepts that are semantically different to be more distant. But how do we know that executive assistant to CEO is a very different role of CEO, but very similar with executive assistant to chief operating officer? And this is the domain knowledge from the domain of jobs. Therefore, in order to do job title normalization, we cannot just take a pre-trained model and directly use it for our task. But first, we need to adapt it to our data. So we consider different types of deep learning architectures that were fine-tuned using an in-house developed list of raw job titles and their respective normalizations. We tested these fine-tuned models on different use cases, and we chose the best performing model as our production service. And we refer this model as the English SIG normalizer. So now we have an English model, but this is not enough for SIG's use case, because besides Australia and New Zealand, SIG operates in 6 other countries throughout Southeast Asia through our local brands there, JobStreet and JobDigBree. It also operates in Brazil through Cato, which is our local brand there, and in Mexico through OCC. So we need to be able to normalize also texts that are in a non-English language. Another reason for which SIG needs to adapt their products and services to the local data from various markets is because this data doesn't reveal only characteristics of the specific language, but also cultural norms and common sense knowledge. Even in countries where English language is predominantly used, this common knowledge varies across markets. And for these reasons, here at SIG, we have to create multilingual models. We then define 4 main approaches to train multilingual models. The first one is to train a model from scratch. That was also mentioned by Case. This approach has a significant drawback that it needs massive parallel data, computational, and time resources. The second approach is using a pre-trained model for the language that we need. This approach is easier to obtain, but it doesn't contain the domain knowledge that is so important for SIG. The third approach is to fine-tune a model in the target language, as we did with our English language. However, we have more training data in English than in any other language. Therefore, we chose the fourth approach, which is a cross-lingual model that transfers the knowledge from one language to another. For this, we took the fine-tuned model for the source language. In our case, it's English, so we took the English-Seek normalizer. We chose a multilingual pre-trained model, publicly available, that contains the target language, and we train it with a set of pairs containing English job role titles and Thai role job titles, because in this case we want to fine-tune for Thai. But the way how we train the way how we fine-tune the pre-trained model is that we trained it considering the information that was already encoded in the English model. And this is how we got our Thai-Seek normalizer. Next, when we want to train for a new language, we use the Thai-Seek normalizer that already contains domain knowledge from English and Thai, and fine-tune it with a new language. In this case, we chose Bahasa Indonesia. And we get a new model that is trained on English, Thai, and Bahasa Indonesia. And we continue like this for each language that we want to tackle. So a few learnings are that with transfer learning, we get better results with less time, samples, and cost. When we want to fine-tune a model, it is important to choose a pre-trained model that is trained on a similar task than your task. Definitely, but we need to pay attention to the data quality and labels. What you give to the model to train on, this is what it is going to learn. And also remember that model building is not a one-way process, but a recursive process. So don't forget to look at the data and always do an error analysis. And thank you very much for your time. Do we have time for questions?
Much. Now we begin with the second half. The second half, we have two more talks. So to present our next talk, I would like to invite Trevor, who's a principal data scientist in the search and auction squad. So over to you, Trevor.
Hi guys, Trevor Yan, lead data scientist for the search and auction squad. For search and auctions, we do search. You put in some details of what sort of job you're interested in, and we come back with a set of jobs, and that's what we do. It's an important part of Seek, and we do that the best we can. Got a great team for doing this, a multidisciplinary team with data scientists, with NLP expertise, with information retrieval expertise, as well as general machine learning. And a great set of software engineers and search quality experts that go through and make sure that our results actually make sense. And at the same time, we have a set of product managers that make sure that everything's sort of lined up, that we're doing things that make sense across all of Seek. This is pretty much global scale stuff. We have a job inventory of well over a million jobs, probably more like 2 million jobs. We have thousands of searches every second. That's burst times that'll be very large numbers, lots of sites, lots of languages. We need to make sure that all this works really fast, gives answers, even though we're querying this across enormous numbers of jobs. So it's quite some interesting constraints that it puts on the sort of techniques that we can use. I'm not going to go through much of the sort of things that we focus on. There's just not enough time. We'll have a bit of a glimpse at some of the query understanding stuff that we do, the sort of things that that we do when a query first comes in before we get to trying to match it up against a job. So query understanding, we're just trying to work out what the user wants. What do they intend? What are they trying to find? And these tend to be pretty short. They're not typical NLP structure where you've got a whole lot of syntactic clues around what's there. We don't get this senior data scientist job located in Richmond, Melbourne. It's just a bunch of words, senior data scientist, Richmond, Melbourne. So there's not much in the way of extra clues there for us. And then it's a matter of what can we use to understand that intent. Can we use data about past user behavior? Can we use data assets that we've got? We've got teams, marketplace knowledge, put together a whole lot of assets for us that that can be used to work out what sort of companies, what sort of locations, what sort of roles we have, and how can we use those? And I will not go through the segmentation definition there, but to say that basically we're trying to break things up into sets of concepts, and sometimes we'll have mixes of them. In the case of data scientist Richmond, there's a role there and there's a location. Okay, two things. It's a little bit like entity recognition, but without the rest of the syntactic clues that we might have there. And there's some interesting ambiguities that we have there, even, and in fact, because we have these assets that tell us what a location is. So we go through, segment things into pieces, and we tag to work out which of these will be locations or other types of concepts. And there's some special problems there's some examples here from Victoria. Health officer. Officer happens to be a location in Victoria. It's a town, lovely town. But it means when you're talking about health officer, you have to worry about, well, am I talking about health officer as a role, or am I talking about health as a type of area that I might be employed in, and officer as a location? Research, also a location in Victoria. Thanks whoever's picking these names. Research officer, again, probably more likely a role title than two locations. We do have information about those two locations and can look at that to see whether it makes sense to talk about them together. And I won't go into detail here, but this, and particularly not with the example, because I can't read traditional Chinese. But what it comes down to is that you really don't want to treat this tagging and segmentation as independent tasks that you do sequentially. You really want to do them at the same time. And you use all of the information you've got to do both of these things. The example there is something about homework and tutors, and I don't know, and primary school, there we go. Anyway, that's just a quick look at one part of the problem that we have, and where the sort of query understanding sort of fits in, just simply splitting things up. And we do this not just for machine learning models, but also for some regular text retrieval techniques that we have. So we need a bunch of concepts that we can search for in a very large distributed database, as well as the machine learning models that we have. I'll just have a quick touch on some of the vector-based query normalization that we have. So we want to be able to deal with queries that are the same intent the same way. If you happen to spell the word differently, but you mean the same thing, you should get the same results. And so we try to identify that. And it helps when it comes to machine learning models. If we have two ways of writing things, and one of them is very popular and the other one is not, we'll have a lot of data about the popular one and not so much about the other one. But if I know they mean the same thing, I can have lots of data for both of them. And that's a good outcome when it comes to the machine learning training. And just some examples there, different spelling variants. So we have British English and American English for dietitian. They're both correctly spelt. They mean the same thing, but one of them will show up a little more in Australia than the other, and we should be able to handle both. Spelling errors. This one I like very much. So manager and manger. Now, manger, we're not talking about a feed box for an animal. We're talking about a manager that someone managed to drop the A. And simple things, some plurals, singular. We want to make sure that we do the right thing there. And lastly, they're just looking at gendered role titles, what sort of things we can do to make sure that if you search for something that happens to be gendered, that we have, we give the right sort of answer, the same sort of answer, so that you end up with whatever your gender is, that you're getting good answers and they're complete. Quick dig through the sort of approach that we've taken here. Our initial approach has word embeddings that we're using. We have tokens that are split out by a multilingual tokenizer that we have put together, and we pick out the top similar tokens within that embedding space. We go through and do some additional checking edit distance wise to make sure that we're not doing anything a little too aggressive. We would rather miss some things than get them wrong. Precision more important than recall. And then we build a graph to capture the transitive sort of connections there and pick out a canonical form, the one that has the most behavior. And at that point there, we can normalize queries for that particular word, which happens to work pretty well. Looking at different sorts of embedding models, and they have different sweet spots, better for spelling errors, better for spelling variants. So a pretty good outcome. There's still more that we could do. We can build this around the sort of query segments that we identify so that we can look at multi-word sort of concepts. Same using something like SentenceBird to use more than one word at a time. And that's pretty much it. It's a very, very short sort of glimpse of some of the stuff that we're looking at. The big deal is that we return matching jobs. Query understanding is just the start of that. We have a lot of jobs that we have to pull information out with different NLP techniques and do ranking and retrieval. And lastly, we have related search, which goes through and suggests other searches. And in that case there, we currently use a generative language model. So we use that for generating a whole lot of different suggestions so that when you do a search, you look at the jobs, you're not really satisfied with it, we'll give you a set of alternative searches that you can have. And as I say, just the beginning of some of the stuff that we're doing in search. There's a lot to look at, a lot that's interesting, and a lot that we still have to try new things for. And that's it. So, any questions?
More questions? Thank you. Awesome. So it is a privilege to be the last speaker in today's lineup, which is me. So I will be talking you through NLP in the recommendation squad, and this is the part where I have to be serious because this is my work at Seek and the work of the team that I belong to. So my name is Aditya Joshi. I'm a data scientist in the recommendation squad, which I'm going to refer to as Rex because that's how we call ourselves. So if I say Rex, please do not be confused. I'm referring to recommendations. Our purpose at Rex is to help candidates discover relevant jobs and content based on profile, preferences, past behavior, and context. And some of you at the beginning of this meet mentioned that you have actually seen Rex on the Seek app, either in the form of push notifications, the homepage, or the post apply. This is what our team looks like, keeping in mind the name of today's event, Global Scale NLP. We are actually 20 members who were born in 9 countries and who are based in Australia and Malaysia. Like all squads in AIPS, we are organized in engineers, data scientists, and product managers. I think we have Soumya and Ed from the Rec squad here in the audience. Recs on the Seek app are found in many forms. So we have a homepage section where we have about 5 recommended ads. We have push notifications and emails that get periodically sent to candidates. Some of you have actually mentioned these recommendations to me earlier today. We have a dedicated recommendations page, which is a long list of recommendations. And finally, when a candidate applies to a job, they get to see related jobs as a post-apply recommendation. While all of these recommend jobs to candidates, which is the underlying theme, I'm sure you can appreciate that these recommendation algorithms differ and have very interesting nuances. While push and emails need to be fresh because they are sent periodically to candidates, recommendations page is a long list of recommended jobs. So what we do at recommendations is essentially implement real-time recommenders with different business objectives, markets, frequencies, recommendation lengths, and families of recommender algorithms. And when I think of global scale NLP at Rex, I think this is the scale that we are thinking of and working with. A typical recommendations pipeline resembles a typical data science pipeline, where we have data, which gets organized using features as a feature engineering step. Then we have a suite of recommender algorithms which recommend these jobs to candidates on their phones or their browsers. Where does NLP feature here? NLP features at both the steps of feature engineering and recommender algorithms. These are some examples that I've listed here. We use NLP in the form of data normalization, enrichment, and semantic search when we are generating features from job ads. And in terms of recommender algorithms, we have been working on using NLP features, as you can imagine, in the form of n-grams, information preserving projections for collaborative filtering, and so on. Not related to NLP are these 2 papers at the footer of this slide. You can barely see them, but they are from ACM Rexis 2021 and 2022, where we have talked about recommender systems in the context of what we do at Seek. Today, I'm going to talk about just 2 of these aspects, data enrichment and representation learning, just to give you a flavor of the NLP that we do at Rex. So let's quickly jump into the first part, which is data enrichment. The objective here is to enrich data from job ads and candidate CVs by extracting structured information. We view this in 2 phases, the querying, the indexing time and the querying time. In terms of the querying time, what we're trying to do is we are trying to extract structured information from job ads. While job ads are unstructured text, we want to make sense of them by extracting important information. And I would like you to focus on the data enrichment block there, where we use a mixture of GenSim, scikit-learn, NumPy, and SciPy to extract important information from the text ads. At the querying time, we use request handlers, which essentially query the required job and the corresponding index for us. This pipeline, as you see, uses a bunch of technologies such as Scala, Spark, and Solr. But what I would like to focus on and draw your attention to is typical NLP problems that we deal with. So we essentially deal with information extraction, named entity recognition, and do some sort of lemmatization and stop word removal to clean up some of these ads. Let's dive deeper into the data enrichment block that we had there. So given a job ad, we want to extract information from the job ad. And this diagram here somehow reminds me of the layers of NLP as we study them. So we start with a job ad. We first have a text normalization step, which would handle special symbols, verb inflections, spelling corrections, and so on. The next step would be to parse some of these documents and job ads in order to extract entities. Then we also expand queries similar to search and auction squad. Then we add personalization, semantic ranking, and so on. So the goal of this step is to start with a job ad, which is unstructured text, and reach a point where we have structured information about the job ad, from which we can create indexes, features, and essentially use eventually in the recommender algorithms. The second part of the recommendations pipeline that I would like to talk about is in terms of representation learning. So the objective here is to build a generic pipeline that can learn representations using a large suite of semantic representation models. So I'd like you to think of this as a Hugging Face for the Seek's use case. So this is a pipeline which allows us to train different kinds of NLP models using Seek's data. There are 3 steps here. The first step is a data loader, which uses a combination of Solar, S3, and Databricks with some NLTK pre-processing there. That is followed by model training, in which we have implemented multiple objective functions in terms of similarity loss, sequence classification, masked language model, and context prediction. And once these models have been trained, these models serve in terms of providing representations. So this allows us to learn representations from Seek's data, specifically the job and candidate data that we use in recommendations. I would like to close my talk with just 2 use cases of how we use this pipeline. So the first use case is in terms of learning word embeddings, specifically word2vec. So imagine that we have Seek's job data. We only, for example, let's just be simple and let's only look at the job position titles. So the position titles are postdoctoral fellow, data scientist, and so on. We essentially train a GenSim simple word2vec, which allows us to learn representations, either using SIBO or skipgram. These representations get saved and may be fed into our recommender models in multiple ways. The second approach is slightly more interesting. It actually uses language models, specifically BERT. We need an objective function to fine-tune BERT. At recommendations, we thought, what can the objective function be? We thought, when a candidate applies for a job, they are actually indicating some sort of a similarity or relevance towards that job. And therefore, we fine-tuned BERT in terms of similarity loss. So you see that, here's an example where a candidate who is currently a postdoctoral fellow applied for a lecturer position, a data scientist applied for a senior data scientist position, and a front desk staff applied for a restaurant manager. These examples really represent different kinds of applications if you look carefully. But what this allows us to learn is essentially similar position titles, applications indicating similarity between position titles, and we fine-tuned BERT for similarity loss. We eventually ended up using these representations in some of our experiments. So therefore, while we conduct NLP at recommendations, we acknowledge 2 things. NLP techniques provide a mechanism to power recommendations by obtaining structured information from ubiquitous textual data on Seek. So there's just so much in terms of job ads, candidate CVs, and so on. And we have been hearing about it in different forms today. The second promise of NLP lies in that we can actually integrate this into our recommender pipelines by learning some representations. And as of now, I've discussed 2 use cases for word2vec and BERT. And that's it from me. Thank you very much. This was about NLP at Rex. Thank you. I think we are out of time. So now we've come to the end of the 4 talks. Thank you very much. Before we close, I would like to invite Terry, who is a principal data scientist in the candidate quality squad, to give us his closing remarks and close today's event. Thank you.
Thanks, Aditya. I'm not going to take up much time because we are, I think, already out of time. And so first thing I want to do is just maybe give ourselves a big round of applause. Thanks for everybody for coming out tonight. I think the audience is who I want to thank for the first. And there are a lot of other people who deserve thanks: the NLP Meetup organizers, the sponsors for the NLP Meetup, all the people at Seek who made this happen. It's not that complicated, but it's also not that trivial to pull off. So thanks to all of them, and a huge thanks to Aditya, who did so much work over the past month to pull this together, and then did a fantastic job hosting tonight. And so the last thing that I want to do is a little bit of self-promotion and a little bit of opportunistic promoting the fact that we are hiring. I'm hiring for my team. Most of the squads that you heard from today are looking for data scientists, engineers, NLP people. There are QR codes up around the room if you want to see what positions we have open, or if you're online and you can't scan a QR code, you can just go to seek.com.au and search for data scientist at Seek jobs, and you'll find what I'm talking about. And we've got, I know everybody's probably a bit exhausted after all the talks, but we do have some time. We just still have food and drinks and time to mingle if you want to stick around, ask some questions that you didn't get a chance to ask, get to know some of the people who work at Seek. You can see us with the Seek name tags. I'm very happy to talk personally with anybody who might be interested in any of those job openings, or just interested in what we do at Seek and want to ask some more questions. So that's it for me. Thanks again, everybody, for turning out. I think these meetups are amazing. It's been a big part of my life ever since I came to Melbourne, is the meetup scene. So I'm glad to see people getting back together after the pandemic. It's really amazing. So thanks again, everybody, for coming out.